Hello students, so the question here says one end of a spring of natural length h and spring constant k is fixed at the ground and the other end is fitted with a smooth ring of mass m which is allowed to slide on a horizontal rod fixed at a height h as shown in the figure. Initially, the spring makes an angle of 37 degrees with the vertical when the system is released from rest. Find the speed of the ring when the spring becomes vertical. So, here we have the figure associated with it. This is the ring which is right now it is at a position A. Let us say the ring has a mass m and it is connected with a spring whose other end is connected to, let us say, the point O here, and the spring has its natural length h, which is also the distance between the ground level and this rod that we have at a height h above. So, understand that as we look at this figure, the spring right now is in its stretched position. It is elongated spring, it is not in its natural length, and if we assume that it has a length L, we can actually find out the extension that the spring has by finding out the length L in terms of h and this angle 37 degrees which has been given to us that the spring is making with the vertical, to actually find out the extension in the spring and hence the energy, potential energy that is stored in the spring at this particular instant. So, from here when this system is allowed to move, do you understand, since the spring is stretched, it will pull the ring towards itself. So, this will be the direction of the spring force kx, whose component along the horizontal will be in this direction and will try to take the ring towards left, right. So, the natural tendency of the system will be to make the ring move towards left, and as the ring moves towards left, the spring will become smaller and smaller till the time at a position B where the spring becomes absolutely extensionless. It will be in its natural length because the distance between the points O and B is simply h, which is also the natural length of the spring. So, by the time the ring moves from the position A to the position B, do we understand that the spring will lose all of its potential energy, and all that potential energy of the spring will be converted into the kinetic energy of the ring, because here we know that the ring is smooth. Smooth ring means it suffers no friction from the rod. So, there is no friction anywhere, no loss of energy. So, we can easily use the law of conservation of energy between the points A and B to get our answer here. But before we could get it, we have to get the potential energy stored in the spring at this particular starting position, for which we need to get the length L of the spring, which we can easily get using trigonometry. Here if we look at this triangle OAB, which is a right angle triangle, can we write h by L as cos 37, and cos 37 we know is 4 by 5 by the way. So, from here we can find out the value of L. L will be h into 5 by 4, right. And once we know L, the stretched length of the spring, we can find out the extension in the spring, which will be x, which is L minus the stretched length of the spring minus the natural length of the spring, which is h. So, it is 5 by 4 h minus h, which will simply be h by 4, right. So, once we know the extension in the spring, we also know the potential energy of the spring at this initial state, and now we can directly use the conservation of energy of this whole system between the points A and B, and can simply write the kinetic plus the potential energy of the system initially. Kinetic energy is 0 initially because the ring is at rest, plus the potential energy of the system is nothing but the potential energy of the spring here, half k x squared, is equal to the kinetic energy of the ring when it reaches the position B. Let us say it is half mv square if we assume that this ring has gained a velocity v by the time it reaches the position B, plus the potential energy of the spring will now become 0 because the spring has come to its natural length, right. We can simply solve this equation to get the value of v, which we see can easily come calculated to be v is equal to v squared is equal to, first we can write it as k by m times x squared, and hence v will be root of k by m times x, and now we can substitute the value of x, which we know is h by 4. So, the answer will be root of k by m times h by 4.